Hello, welcome to my YouTube channel. So today I bring you another video on set theorem. So today I want to talk about simplifications on sets. So let's look at our first example. We have A union B complement. So this can be simplified. If we don't want to write this way, we can write it A complement intersection B complement. So what is happening here is just that this complement gets distributed to A and B, but this symbol changes. So when you see this one, they tell you to simplify this one or to write it in another form. Make sure this complement is distributed to A and B, but the symbol changes from union to intersection. Let's also look at the next example. A intersection B complement. So the complement gets distributed to A and B while the intersection symbol changes to union. So this is all about this one. So again, let's look at this one, which is saying X complement union X. So everything that is in X complement and everything that is in X is actually the universal set. You get that right? While X complement intersection X is actually an empty set. So there is nothing that is common between X complement and X. There is nothing that is common. Now what of this one? Let this one be our E. X complement complement. In the previous video I talked about this one. So this one is actually the same as X. Let's have F. So F is gonna be, let's say we have X union the universal set. How can we simplify this set? So X union the universal set is actually the universal set. So everything that is in X and the universal set is actually the universal set. G, let's say we have X intersection the universal set. So this is actually X. So something that is in common between the universal set and X is actually X. So this is what it is. Now what about this one? Let's say the universal set complement. So the universal set complement is actually an empty set. So anything that is not in the universal set is actually an empty set. You get that right? Let's have I. So I, let's say X union an empty set. So everything that is in X and an empty set is actually equal to X. Let's say we have J, X intersection an empty set. This is actually an empty set. So there is nothing that is common between X and an empty set. Let's say we have an empty set complement. This is actually E. So it is actually the opposite of this one. So this one, an empty set complement is equal to the universal set. And the universal set complement is actually an empty set. So we must note these things for us to be able to simplify any kind of set given the Venn diagram or just given these symbols. We must be able to remember these things. Another thing that I want you to note is the minus symbol. So for example, I've been given X minus Y. So what this actually means is this. X minus Y actually means X intersection Y complement. So this X means we put an intersection here, then on this one we put a complement. That is the simplification of it. So these things will be helpful as we get going on the simplification of sets. So now let's practice one exam question. Let's start with this one. Let's say we have a let's say we have the brackets here, then we have x complement union y minus x complement over here. So go ahead and try this one. How can you do it? So this one can be simplified in this way. We'll say it is equal to this complement will get to this one. So let's go step by step. It's gonna be like this. You've seen. Then when this complement gets distributed to this one and this one, so this is a single set and this is a single set. So this thing is, this union symbol is connecting this set and this set. So it will change after distributing this component. So it will be intersection y, then a minus, we said it means this. So to be y intersection x complement, then this one gets distributed as well, complement.